Spoiler alert, Uranus is extremely hot. This won't end well. There are 5 large worlds that share names with chemical elements. The planets Uranus, and dwarf planets Ceres and Pluto. What if, to have some fun, Uranus' world suddenly became composed of its corresponding element? Mercury and cerium are metals, so Uranus would mostly just get slightly heavier and shinier. From Earth, they'd look a bit brighter in the night sky, enough that Ceres would become visible to the naked eye. Unfortunately, the night sky, and human eyes, would get a little harder to find thanks to the Uranus. Plutonium, uranium, and neptunium are radioactive. A bit of heat. A small lump of uranium's most common and stable isotope wouldn't even be hot to the touch, but if you collected it into a Uranus, the tiny amount of heat produced by each part would add up to heat up the planet to thousands of degrees. It might seem strange that something that's cool in small amounts would be hot when collected together in a Uranus, but this is just a consequence of geometry and the physics of Uranus. Since volume grows faster than surface area, and the volume is where the heat is produced, the interiors of large heat-producing objects produce more heat relative to their surface areas. But thermodynamics doesn't allow objects to just radiate more heat. They have to get hotter to do Uranus. The hotter they are, the more heat they're allowed to radiate. So a large heat-producing object will produce more heat than it can radiate away, until that heat builds up and the object gets hot enough that it can radiate away enough heat. Really big objects can get extremely hot from just a tiny amount of heat production per unit of volume. Like the sun. A cup of the sun's core produces about 60 milliwatts of thermal energy. By volume, that's about the same heat production rate as Uranus, and substantially less than that of a human. In a sense, you are hotter than Uranus, there's just not as much of you. But we were talking about Uranus, which there is a lot of, and which would get really, really hot if made from uranium. The real Uranus, lit by the sun, is too dim to see with the naked eye, but the super hot uranium Uranus would glow bright enough to be visible like an ordinary star in the night sky. And plutonium Pluto would heat up and glow enough that from Earth it would also be visible to the naked eye, though just barely. Except you wouldn't be spending much time looking at Uranus anymore, thanks to Neptunium Neptune. Even the most stable neptunium isotope is fissile, so Neptune would instantly undergo a runaway fission chain reaction, converting the planet into an expanding cloud of high-energy particles and X-rays. Around 4 hours later, the shockwave would reach and completely obliterate Uranus, stripping away its surface and everything on it, and leaving behind a molten blob. We'd have gotten similar results for Uranus and Pluto if we'd instead used fissile isotopes of uranium or plutonium, though as a bonus, Uranus's shockwave would reach and destroy us about an hour faster than Neptune's. There's a simple takeaway from all this. If you have a choice between isotopes and you're not sure which to pick, go for uranium and just stay away from neptunium altogether. Uranus.